Welcome to the Natural Health Podcast, where we bring awareness of sustainable health in the business hustle space. The Natural Health Podcast is perfect for the high-performing, business-minded individuals who want to work with their biochemistry to achieve optimal health. Let's get straight into it. I've got a few questions for you. So if you suffer from headaches, migraines, anxiety, addictions, phobias, ADHD, miscarriages, fertility issues, anything along those lines, you have probably heard of methylation or even the MTHFR gene. But how are they all linked with methylation and the MTHFR gene? What does all that even mean? There's so much science behind it, but in simple terms, I'm going to be talking about today what is methylation, what happens if you over-methylate or under-methylate, what effects that might have on your body, and then I want to talk about improving how you're able to improve your methylation cycle so you achieve optimal health. Let's get into it. It's Mondays with Mihaela. That's right, me. Thank you so much for tuning in. I absolutely love, and appreciate your support. For any of you who don't know me, my name is Mihaela. I'm a qualified naturopath, absolutely passionate about all things health, business, and overall success. And Mondays with Mihaela are here to provide you with simple, savvy, and sustainable health hacks to optimize your health. That's exactly why today I want to be talking about methylation. Methylation is an absolutely huge topic. You would have probably heard about it. People getting their genes tested, the MTHFR gene in particular, getting it tested to see if they have it. And then when they do have it, to see what effects that has on their body. The MTHFR gene has an absolutely huge effect on your body. But little did you even know or think about that it might impact your headaches, your migraines, your fertility, your behavior, your anxiety, your phobias even. But that's what I want to talk about today. I'm going to go and link it all together, so explain to you in simple terms how that all may link and make a link to yourself and your body so you're able to live an optimal life, right? So let's get straight into it. So what is methylation at all? I may use big words, but don't stress too much about them today. If you have any questions, contact me and I'll go into more detail. I'm going to try and make it as simple as possible. I do want to put it out there that methylation is a very complex topic. Not only methylation, but genes in itself and enzymes and all these things that I'm going to be talking about. It's so complex that I'm only taking a little bit and making it simple for you, right? So essentially, right, methylation is a fundamentally important biochemical process whereby a methyl group consistent of one carbon and 3 hydrogen atoms. That is a methyl group. So that's 3 hydrogen and 1 carbon. Put them together, that's a methyl group, right? And that is transferred to a substrate such as DNA, RNA, neurotransmitters, hormones, immune cells, or nerve cells, right? So then these newly formulated methyl compounds can then complete their task in the body, which includes detoxification, DNA and RNA synthesis and repair, gene regulation, neurotransmitter production, hormone regulation, energy production, cell membrane repair, fat metabolism, myelination, and immune function. So you have these 3 hydrogen and 1 carbon, which is a methyl group. Then this methyl group, what happens to it? It gets joined to DNA, RNA, neurotransmitters, hormones, and whatsoever, and then it's able to complete its job. So that's what methylation is. It gets methylized, if you want to call it, if that's even a word. So without this methylation occurring, at the end of the day, you won't be able to either detox or synthesize your DNA or RNA, or repair, or gene regulation, or produce this neurotransmitter, or produce or balance your hormones, produce this energy, health cell membrane repair, fat metabolism, and immune function. So that won't be able to occur if you don't have this methyl group. coming on, right? So when methylation is impaired, this process becomes compromised and ill health arises. That's what happens, right? So when no methylation, when you're under-methylating, which I want to go into detail, when you're under-methylating, so you're not methylating enough, issues occur. When you're over-methylating, like that's happening way too much, issues occur. We need a balance. We need a balance of methylation so it happens and helps out your body, right? Interesting fact that I want you to know is that methylation occurs billions of times every second and involves several pathways, including the folate and methionine cycles. So methylation doesn't occur in itself. If you actually look at I might actually put a chart up right over here. If you look at the cycles, it's so complex. There's the methylation cycle there. There's the folate cycle there. There's the methionine cycle there. There's so many different types of cycles occurring at the same time. Like our body's so complex, and we're just talking about this one cycle in our body that has brought on a lot of attention, right? So when you have optimal methylation, there are positive effects, right? So when it's in the middle, everything's happening the way it's supposed to be happening, right? You have amazing DNA production, your neurotransmitter production is on point, you're detoxifying all those toxins out of your body on point, your histamine metabolism is on point. Remember how I spoke about histamines? Estrogen metabolism is on point, your eye health, your fat metabolism, cellular health, liver health, reproductive system, energy, and so forth. Everything's happening the way it's supposed to be happening, right? So now we're talking about the methylation cycle, right? It includes several genes, a number of enzymes that play an important role in numerous metabolic pathways, right? So some of the genes that are responsible are the MTHFR gene, right? Which a lot of people get tested, right? And they may have a SNP on it or they may not have a SNP. Depends on what their gene results say, right? And this is responsible for the production of, I'm probably not going to be able to pronounce it, but methylene tetrahydrofolate reductase, the enzyme involved in the conversion of 5,10-methyl, long name right there, right? So this is what I'm talking about. It's very complex and sciencey, but essentially in a methylation cycle, we have the MTHFR gene, right? So a lot of individuals just test the MTHFR gene. I want you to know that's not the only thing that's involved in there. There's also the BHMT gene, the CBS gene, the MTR gene, the MTRR gene, right? And the gene tests that I run actually test most of these genes. So you put the whole picture together. It's not just about the MTHFR gene now, it's about the methylation cycle, which includes the MTHFR gene, BHMT, CBS gene, MTR gene, MTRR gene, which are responsible for so many different things, right? Synthesizing reductase and so forth, all of these chemical reactions in our body that they're responsible for, including vitamin, B6s, B12s, kidney, liver. There's so many things that are associated in mitochondria making energy and so forth, right? But now that you kind of know a little bit on a simple way of what methylation is, what can go wrong with it, right? And this is where I want to spend most of my time, because this is what you guys are feeling, the signs and symptoms that are coming up, and I want you to understand that, right? So the folate and methionine cycle involved in methylation are highly dependent on an adequate supply of several nutrients. And these nutrients act as cofactors. Remember I've spoken about what cofactors are. These cofactors are needed to ensure an outcome is achieved. So for example, it's kind of like to make an apple cake, you need flour, water, so forth, but then you need to whisk it, combine it, bake it, right? These are the cofactors in it. So this is what's key to make the apple cake. This is what's key to make the body function, right? So without an adequate supply of these nutrients, and these nutrients are, you ready for it? Are you ready to write it down? B9, B2, B6, B12, serine, choline, your methylation imbalance occurs, right? So what do we know that reduces our folate, our B2, B6, B12, choline, and so forth in our body? Foods, right? Carbohydrates, heavy imbalanced carbohydrate meals. What else? Food colorings, flavorings, preservatives, stress, immune dysfunction, so forth, reduces the balance of these in our body, right? Which then our methylation won't work the way it's supposed to work, right? An inadequate dietary intake of these nutrients, a nutrient malabsorption, so gut issues. If you have any gut issues, you're unable to take on these nutrients and make what you're supposed to make out of them, right? And medication that depletes nutrient levels can cause methylation imbalances. So medications in there also. Medication can reduce or increase your methylation depending on what it is, right? So a SNP, which is SNP, which I'll talk about in regards to genes, it's actually called a single nucleotide polymorphism, including MTHFR polymorphisms, are also significant contributions to methylation imbalances. So what I mean by that is let's say your mum and your dad, right? Let's say they have a SNP, your mum and your dad both have SNPs in their MTHFR gene, or let's say, for example, your dad has a SNP in his MTHFR gene, your mum's all good, and then you end up with the SNP in the MTHFR gene, which means then even if you live the best lifestyle you can, you still have a 25, as we say for genes, chance of having a methylation issue, right? But then there's also the environmental factors that contribute that. The way I look at it like this, right? Let's say you've got 4 lanes on a highway, right? You've got 4 lanes on a highway, all going to, let's say, Sydney, right? From Melbourne to Sydney, you've got 4 lanes, right? Because you have the MTHFR SNP, you're reduced to 3 lanes, which means you still function, right? It's just reduced by 25%, the way you can get to Sydney, right? It's reduced by 25%, okay? So now you have, instead of 4 lanes, you have 3 lanes, which means you still get to Sydney, you still get there pretty fast because those 3 lanes are going pretty fast. But then what can happen is you incur stress, a divorce, a bankruptcy, a job issue or something like that. So what happens is this lane's closed and this one has a car accident, right? So it's kind of like you have 1.5 lane now available. It's like you're not really going to get to Sydney as fast with so many cars, right? And then you eat junk food and then there's more cars going through and then you only have 1 lane. So you've gone from 4 lanes to 1 lane due to your genetics and your environmental choices and your lifestyle, right? So what I'm trying to say here is you play a role in your methylation cycle, right? It's not just your genetics, right? So factors such as alcohol intake, cigarette smoke, stress, environmental toxicity can all result in methylation imbalances. So even though you only got given 3 lanes compared to Bob down the road who has 4 lanes, but Bob down the road, even though he has 4 lanes and he doesn't have a methylation SNP, he may be smoking, drinking compared to you're not. He may only have 2 lanes available. All right, let me go back and straighten that forward. Okay, so you have, everyone's given 4 lanes, let's say to go Melbourne, Sydney, right? You have a methylation SNP, which only gives you 3 lanes, right? Bob down the road has no SNP. You don't smoke and drink alcohol and eat junk food. Bob down the road does, which makes his 4 lanes now to 2 lanes. So can you see now that even though you may have the SNP, you still have more lanes than Bob has because you're living a healthy lifestyle and you're supporting your methylation cycle, right? So what I'm trying to say is genes are not the end all, okay? They have a lot to do with it, but they're not the end and all. It's environmental factors. It's the choices that you're doing to make sure you have those B vitamins, the serine, and so forth to make your methylation work. Okay. So what happens? What can happen if this methylation doesn't work properly? Right, these lanes. Right, it can translate to ADD, ADHD, allergies, autism spectrum disorder, bone fractures, cardiovascular disease, cancer, chronic viral infections, cognitive decline, diabetes, immune dysfunction, fertility issues, molecular degeneration, migraines, mood disorders including anxiety and depression, multiple sclerosis, neural tube defect, neuropathy, pregnancy complication, and thyroid dysfunctions, right? This is what can occur if your methylation is not working the way it's supposed to be, and it's a very complex system. So like I said at the start, you can under-methylate and you can over-methylate, what we spoke about at the start, right? If you're under-methylating, right, what can happen is you can have obsessive compulsive tendencies, frequent headaches, several phobias, chronic depression, even suicidal thoughts. So individuals who have suicidal thoughts may be under methylating. So, the food that they may be eating may be depleting them from the nutrients that will help them methylate, right? Addictions, delusions, social isolation, bulimia. So what you can think about here, let's say, for example, addictions runs in a family. Does the MTHFR gene run in a family? Do the lifestyle factors and contributions to the body run in a family? You know what I mean? If there's addiction in the family, is this addiction due to genes and lifestyle factors, right? MTHFR, methylation, how is that going? It's the number one thing I think about when someone comes to me with an addiction is how is their methylation, right? Or when someone comes to me with fertility issues or brain issues, anxiety, depression, right? When you're over methylating, right? It results in a high level of serotonin and dopamine, which can cause psychological issues, right? Frustration, dry skin, hyperactivity, anxiety, sleep disorders, restless legs, low motivation, depression, and so forth, right? So let's have a look at specific parts in our body, how methylation can affect it, right? So what can happen, right? Number one thing that I want to talk about is cognitive function and brain health, right? Poor methylation may impact cognitive function and brain health in so many different ways, right? So a poor B vitamin status, especially B12, with oxidative stress and inflammation, poor thyroid and accelerating aging, right? Phosphocholine is essential for neural health and is synthesis dependent on healthy methylation. So if all of these things aren't occurring that they were supposed to be occurring, cognitive function and brain health can get downhill, like I spoke about, depression, anxiety, suicidal thoughts, and so forth, right? Now, another one I want to talk about is fertility. Fertility is key. A lot of individuals who have miscarriages may have MTHFR gene mutation, a SNP, right? So low folate and choline and subsequently methylation, because if you have low folate and choline, you have low methylation, are associated with neural tube defects, recurring miscarriages, and a tendency for thrombosis or blood clots, right? Which all of these affect fertility. So as you can see, you have low B vitamins, low choline, low folate, impacts your fertility, right? So it's kind of like, what is the issue? Is the issue low fertility? Is the issue the methylation? Or is the issue low nutrients, deficiencies, right? It's kind of like an ongoing little circle thing. In regards to brain health, I forgot to mention mental health and neurotransmitters. This is an important part to mention because a lot of individuals who have MTHFR SNPs have mental health issues or neurotransmitter issues, right? Because folate, which is B9, is required for the biosynthesis of neurotransmitters, serotonin, adrenaline, and dopamine, right? So the methionine and homocysteine cycle produces SAMe. Complex. I will go into that on a podcast. I'll talk about SAMe, but essentially SAMe is involved in the metabolism of neurotransmitters such as serotonin, dopamine, and noradrenaline. So therefore, methylation is important for the regulation of neurotransmitters and may subsequently impact your mood. Your mood, my mood, everyone's mood. Thyroid. So as methylation can imbalance and compromise healthy detoxification and immune function, as mentioned previously, there's a potential contribution to autoimmune diseases, right? Conditions such as Graves and Hashimoto's, which are thyroid issues. So exposure to certain toxins within the environment, because our environment is so hectic at the moment, isn't it? And we're exposed to toxins all the time. And this exposure to toxins in environment and diet has been shown to impact healthy thyroid function, right? So as compromised methylation can interfere with normal detoxification processes involved in the clearance of these toxins, right? Imbalance in the pathways can impact thyroid health dramatically. So folate is also required for the bioprotection cycle, which is needed to convert tyrosine to its active form, and tyrosine is an essential building block for thyroid hormone function. So you can see in a number of ways how methylation can impact your thyroid or thyroid issues. So if you or someone you know may have thyroid issues such as Graves or Hashimoto's disease, well, do they have an MTHFR gene dysfunction, as in a SNP there, or are there, or is there lifestyle factors impacting their methylation cycle? Because your methylation cycle can be impacted by your environmental or your, lifestyle factors. It doesn't just have to be the gene. But if you have the double whammy of the genes and the environment, your thyroid and mental health can be majorly impacted. Another one that I want to talk about is gene expression and DNA synthesis. As I mentioned above, I spoke about if methylation is going on point, then your gene expression and DNA synthesis is on point, right? Why do we even need that? Well, DNA methylation is one of the epigenetic mechanisms cells use to regulate gene expression, including silencing some genes when it's important for normal genome's regulation and development. So you may have a gene, let's say, to have, let's say Hashimoto's, right? But you may need this DNA methylation to occur to silence the gene, right? Because you want to silence the gene. So you need to have the right gene expression on point. And methylation helps out with this, right? DNA methylation is an important number of cellular processes, including development of the embryo, gene expression, aging, carcinogenesis, and chromatin structure. So DNA methylation describes the addition of a methyl group to a DNA strand. So this is what I spoke about earlier, right? So DNA methylation, what it does is it's got the methyl group, adds it to a DNA strand, which will modify the function of the gene, underactive, overactive, right? Which is really, really important. So it's carried out by enzymes, which I've spoken about. So in regards to this, the key is folate, which is B9, is required for DNA synthesis and repair. Repair is key. You need repair to occur. B9 is also needed to transfer a methyl group to uracils, which is found in RNA, to convert it into thymine. The DNA T that teams up with the adenine. So this is going a little bit more scientific. So this is essentially saying that if you have poor B9, folate status can result in compromised level of thymine, which may result in a subtraction of thymine for DNA sequence, right? Which is a huge issue. It may not seem like a big issue. It's like, oh, it's nothing, but this is actually huge, and it can trigger the process of repair, the defect, and increased frequency of these breakdowns, right? So given the fact that methylation and DNA synthesis, replication, and repair is important to support balance of methylation for optimum conception and pregnancy outcomes, right? So what we need to understand here is we need methylation to occur properly to be like, hey, you gene, please be quiet, and you gene, please activate yourself and replicate, right? And we need to repair you because you're missing this, right? So without methylation occurring properly, you're unable to do this, right? The other thing is also due to this methylation cycle, is something doesn't go well, what occurs is our homocysteine goes up. A homocysteine is a huge marker for cardiovascular disease, but not only that, individuals who have high homocysteine essentially also have issues with fertility. So when you're getting your blood test done next, if you have issues with fertility or cardiovascular issues, it'll be really interesting to get your homocysteine tested, right? The other one, I know there's so many things, right? So many things. I might just go and talk about them just in short so you understand. Immune function, right? Immune function is huge. DNA methylation appears to play a role in modulating systems' wide immune-related functions. So this is absolutely huge, and this is why it's important. So they're mentioning here optimal and balanced methylation is important for the immune system. This is part of the reason why DNA methyltransferases such as DNMT are the subject of much current research on cancer, right? So it's a very interesting, it's a gene, it's called DNMT1 and DNM2, right? They are dependent on obtaining a methyl group from SAMI, which I spoke about earlier, and it produces an outcome as well, functioning folate methylation cycle. B9 again, there we go, right? Inflammatory condition, I mean, who doesn't have an inflammatory condition these days, right? They're left, right, and center popping up, but poor methylation may result in a compromised transphosphorylation, and as a result, poor glutathione production. Glutathione is like the master antioxidant. If you don't have enough glutathione, that it's going to affect your body somehow, right? And this is why, as I'm mentioning and as I'm going through all of this, you're like, oh my gosh, methylation is so important. Yes, it is. And this is why it's such a hot topic and has been a hot topic for a number of years now, and trying to get the message out there that you need to ensure that your methylation cycle is on point, right? So poor methylation is associated with oxidative stress. oxidative stress. I keep talking about oxidative stress so many times with so many different types of diseases, right? And so this is how it can affect inflammatory conditions. Another one is detoxification. So I'm talking about detoxifications of estrogen, hormones, neurotransmitters, and xenobiotics, including glyphosate, arsenic, and so forth. They heavily rely on methylation, right? So if you have too much estrogen in your body, if you have too many hormones in your body, if you have too many neurotransmitters in your body, too many glyphosates and so forth, it's definitely going to affect your methylation cycle. Or it may be why you have so many of them, because your methylation cycle is impacted, right? Mitochondrial health. Oh my gosh, I love mitochondria because it's what gives me energy. It's what gives you energy, right? So mitochondria is highly affected by methylation. Also, another one, which is the last one, is cancer, right? Given the impact of methylation on DNA synthesis, the repair, the replication of DNA, you can just understand how important it is to optimize and balance methylation, right? Because what happens in cancer is this goes out of whack, right? It's not repaired, it's not replicated away, it's not synthesized the way it's supposed to be. So just to the bottom of it, if you want your DNA to be synthesized, made, right, optimally, you want it to be replicated optimally, and you want it to be repaired optimally, because some DNA isn't going to go the way we want it to go. So you want it to go, oh my gosh, you want it to turn on its kill mode where the cell kills itself, right? Yes, that does happen in our body. It's kind of like, it's going to be like, well, I'm not okay, I'm going to die, right? And if that doesn't happen and those get replicated, this causes disease in our body, right? So what happens is, it's a tricky area, you know, researchers are doing some research on that, in particular with follow pathways methylations to prevent cancer and so forth. So much research out there on that. But essentially, altering DNA methylation can be a component of cancer development by proliferating cancerous cells in some way, may silence DNA repair genes, right? What triggers alterations in DNA methylations is still a question, and it's still on research, right? But it's definitely something to think about. So as I've mentioned so many things that can go wrong if your methylation cycle isn't well. I've spoken about cognitive function, fertility, mental health, neurotransmitters, gene expression, repair, synthesis, cardiovascular disease, immune function, which falls under absolutely everything, inflammation, oxidative stress, detoxification, mitochondria health, cancer. There's literally like everything in our body, right? Absolutely everything in our body. Our liver health, our kidney health, everything impacts it, right? So now that you know what can go wrong, so now that you know what methylation is, what happens if you're underactive or overactive, what can go wrong, and how it affects our body, well, the next question is, how can we improve our methylation cycle? Well, there are so many ways that we can improve our methylation cycle, and I'm just going to talk about a few of them, right? The number one thing is medication and medications, right? So some medication can influence the methylation cycle, right? So it is recommended highly that you review your drugs activity that you're on, the drugs that you're on, and talk to your doctor or healthcare professional to see if it affects methylation, right? Some of the drugs that negatively affect methylations are the ones that affect the B9 folate pathway, such as cancer drugs, right? In addition to that, it can also impact B12 absorption, right? So such things as nitric oxide, antibiotic medication, metformin, antacids, bile sequence, and so forth. So the thing is what you need to know about is what drugs are you on, and is that helping or not helping your methylation cycle? In addition to that, alcohol and environmental toxins, right? Toxins include alcohol, heavy metals, chemicals, biotoxins. They all affect our methylation cycle, a detox cycle, which is what I spoke about earlier. If you're not detoxing well, your methylation cycle is not going well, right? In addition to that, one of the big ones is stress, right? So studies suggest that an interaction between environment, stress, methylation has impact epigenetic changes, right? It's important to manage your stress for your methylation to go on point, because when we're stressed, we deplete ourselves of so many vital minerals and vitamins, including most vitamin Bs, and most of the Bs that I've spoken about are key for our methylation to function well. So if you get anything out of this podcast, I want you to get this out of it, right? You're stressed, your B vitamins are down, which means your methylation is not working well. Because you need those B vitamins for your methylation to function well, right? So if you get anything out of this podcast, get that out of it, right? So some people are like, I want to take some vitamins, minerals, foods, and whatever. I'll mention a few that are absolutely key for methylation if you get this through supplement, through your healthcare professional, or through food, right? B9, but it has to be 5-MTHFR, which is the active folate, right? You want the active vitamin B12, active vitamin B6, active vitamin B2, choline, serine, and bonus ones are your magnesium, vitamin D. So there you have it. I've given you so much information about what methylation is, what can go wrong, and then how you can improve your methylation cycle. Because think about this, when you improve your methylation cycle, you're improving everything that we spoke about that can go wrong, right? Fertility, inflammation, cardiovascular health, thyroid health, immune function, DNA repair, synthesis, and so forth, right? By improving your methylation cycle, you'll maybe able to impact all of those things just like that, right? Please talk to a healthcare professional before you make any changes of those supplements that I've spoken about, if you're adding them into your diet and so forth, right? Well, we've come to the end. I hope that you have a clearer picture of what methylation is, but not only that you have a more in-depth picture of how important methylation is in your health, in your everyday health. Like I said, it happens every single second, so many times in our life, and you need to make sure it is on point. Well, do what you do best. Love, like, share, rate, review the Natural Health Podcast. Until next Monday, love you.